Alright, so what this is here, this is a practice FRQ that I have written, and we're going to go over it, or at least one of the 4 sections, right? There's the multiple choice no calculator, multiple choice calculator, free response no calculator, and free response calculator. So I'm just going to be going over the first of those, which is the multiple choice non-calculator section. Okay, so I have scaled this down by a factor of half, so the practice test is half the size of the actual AP exam, and I've also scaled down the times accordingly. I recommend that if you take this test by yourself, which I really recommend you do, maybe pause the video, go and print out the test, which I've attached in the description. Go print that out, take it, set a timer, and then come back and check your work with me. Don't go beyond the time allotted that I've given you for each section. There are solutions at the end, so if you go scroll all the way to the bottom of the PDF or the document, there's this list of all the free response and the multiple choice correct answers. So if you want to watch me do it, that's fine. If you want to just look at the single concise list of all the right answers, that works too. And I'm working on the printable version right now, so there's enough space to work all the problems by hand. There's another version where it's all just problem. There's no space in between. So this is the printable version where I've spaced out the problems. Okay. So without further ado, let us scroll down, and we can see here this is section 1, part A. There's 28 minutes for 14 questions, so you get 2 minutes per question. If you couldn't figure that out, maybe AP Calculus is not the right math class for you. And a calculator may not be used on this part of the exam. That was a joke, by the way. Don't take that seriously, please. Let's use a color. Let's do... the blue is fine. Let's take the blue. Let's start with question 1 here, okay? So, if f of x equals x squared plus 3x over 4x cubed plus 6x, which of the following statements is true? Alright, so we have this list here, and as you can see here, it's basically focusing on 2 different things. Does f of 0 exist? And does the limit as x approaches 0 of f of x exist, right? So f of 0, we can figure that out pretty quickly. F of 0, that's going to be, if you plug in 0 on the top and bottom, we're going to get 0 over 0. So f of 0 clearly does not exist, right? So I'm going to get rid of option C, option D, and option E right away, because those all say that f of 0 does exist. So now we're in between these two, and we're wondering, alright, does the limit as x approaches 0 of f of x, does that exist, right? So what I'm going to do here is I'm going to take f of x, right, and I'm going to factor out an x on the top and the bottom. So on the top, I'll get x times x plus 3, and on the bottom, I'll get x times 4x squared plus 6, right? And as you can see, what this graph really is it's the graph of x plus 3 over 4x squared plus 6, but there's just a hole at x equals 0, right? So it's going to be totally defined everywhere else, but it's only not defined at x equals 0, right? Because the denominator isn't 0 anywhere else. So the limit does exist actually at x equals 0, because it's going to come in and approach the same number from both sides, but that exact point, f of 0, doesn't exist, but it's still approaching the same thing from both sides. So the limit does exist, but the actual number does not exist. So the correct answer here is B. So we're going to go with that. Okay? Let's go to question 2 now. Scroll down a bit too fast here. And as you can see, it's just a very simple integral, right? There's no tricks about it. And as you can see here, we have an x squared term as the exponent for the e, and we just have an x here. So since those are 1 powers apart, the first thing that should come to our mind is, oh, we can do a u substitution. So we'll do that. We'll set u equals 5x squared. We'll take the derivative. We'll get du is equal to 10x dx. And then we'll solve for x dx, because that's what's here, x dx. And we'll get du over 10 is equal to x dx. So I'm going to take this x dx, I'm going to replace it with du over 10, right? So then the integral becomes e to the u, just remember, u is 5x squared, so e to the u du, okay? And then for the bounds, we're going to have, du over 10. And then for the bounds, we're not going to have 1 and 2 anymore, we're going to have u of 1 and u of 2. And by u, I mean we're going to plug in 1 and 2 into here, right? So u of 1 is going to be 5 times 1 squared, which is 5. And then u of 2 is going to be 5 times 2 squared, which is 5 times 2 times 2, which is 20. So what's going to happen here is now we're going to have the integral from 5. I don't know where 10 came from. 5 to 20 of e to the u times du over 10. So I'll factor out the 1/10, and I'll integrate e to the u, which is e to the u. So I'll get 1 over 10 times e to the u from 5 to 20, right? And this is going to be 1 over 10 times e to the 20 minus e to the 5, right? And we can see that's e to the 20 minus e to the 5 over 10, and that our answer choice is right here with answer choice C. By the way, if you're thinking that these two are a bit too easy, don't worry, it's going to get a bit spicier as we go through. Okay, so let's look at question 3. Let f of x equals g of h times x times, let f of x equals g of x times h of x. If h of 2 equals 2, then f prime of x is equal to 4g prime of 2x, find h prime of 2. So like, whoa, what is this? You're giving me a bunch of random facts, and you're giving me this random function. I don't have any real information here other than just some generic functions. How am I supposed to find h prime of 2 here? What the heck? Okay, so what we'll do is we'll just take the derivative of this function because we want to find h prime of 2, right? And we know stuff about f prime of x. So it's a good idea to take the derivative of this function, f prime of x, right? So we're going to start, remember, we're going to start from the outside in when we take derivatives. It's going to be g prime of x h of x. Now we have to multiply by the derivative of this inside function. But since there's two things being multiplied together, we have to use the product rule here. So we're going to get x h prime of x plus the derivative of x is 1. I'm just going to leave h of x alone, so we'll just get h of x. Okay? And now we want to find h prime of 2, so we'll plug in 2 everywhere into here. So we'll get f prime of 2 equals g prime of 2 times h of 2 times x h prime of 2 plus h of 2. Alright? So now let's see what we know. We know that h of 2 is equal to 2, right? So I'll replace these h of 2's with 2's. So I'll get f prime of 2 is equal to g prime of 2 times 2 times, I forgot to substitute the 2 there, my bad, 2h prime, so I get 2h prime of 2 plus 2, alright? And then now we'll see, g of, it's going to be 4, so f prime of 2 equals g prime of 4 times this 2h prime of 2 plus 2 stuff there. And then now what we're going to do is we're going to say, okay, I know that f prime of x is equal to 4 times g prime of 2x, right? So I know that f prime of 2 is 4g prime of 4, right? Because if x is 2, then 2x is 4. So I can replace this f prime of 2 with 4g prime of 4, right? So I'm going to continue it up here. I'm going to get 4g prime of 4 equals g prime of 4 times 2h prime of 2 plus 2. I can cancel out the g prime of 4's. I'll get 4 equals 2h prime of 2 plus 2. Subtract 2 from both sides. 2h prime of 2 equals 2. So h prime of 2 equals 1. And that is option B. Okay? Question number 4. That f of x equals x over e to the 2x. What is the absolute maximum value of f? Okay, so to find absolute maximums, we're going to take the derivative first of all, okay? So we'll start off by taking f prime of x. And so since we're dividing, we're going to use the quotient rule. So we'll have e to the 2x times the derivative, which is 1, minus x times the derivative of e to the 2x, which is 2e to the 2x, over the bottom squared, which is e to the 4x, okay? Now what I can do is I can actually split up this into two separate fractions. I can uncombine them, and so we'll get e to the negative 2x. I'm sure there's like an actual math word for that, but I don't remember what it is, so don't worry about it. So we'll have e to the negative 2x here, minus 2x e to the negative 2x, okay? So I just took this, and I just brought the 2 out, and then 2 minus 4 is negative 2, right? And I can factor out an e to the negative 2x, and I'll get e to the negative 2x times 1 minus 2x, right? And remember, we want this guy to be equal to 0, right? Because that's when the extrema occur, when this derivative is equal to 0. Now e to the 2x can never equal 0, so we're just going to be looking at this guy. And this equals 0 when x equals 1/2, right? So now we're not quite done yet, because when we're looking at absolute extrema, we also want to look at the endpoints. And in this case, since I've not given you any specific endpoints, we're going to look at the entire range of f, right? The entire domain of f, I guess. So we're going to be putting up a table, x and f of x, and we're going to be looking at the endpoints, which I guess are negative infinity and infinity, and all of these critical points, which in this case we only have one, that's 1/2. And we're going to find f of x for each of these three values, and the largest out of these three, that's the absolute maximum, right? But now a little bit, to think a bit about the negative infinity and the infinity, right? Because let's see, if we plug in negative infinity here, we're going to have f of negative infinity. Now it's all very loose, right? It's not really like very well defined, I guess. I'm just kind of going off of instinct here. So if I rewrite f of x as x times e to the negative 2x, I'll get negative infinity times, if I plug in negative infinity into e to the negative 2x, the two negatives are going to cancel out, and I'll just get infinity, right? This is negative infinity times infinity, which is like negative infinity, okay? So we'll say it's negative infinity. And then while we're here, we might as well do infinity as well, okay? So f of infinity, that's going to be, what was f of x again? Oh, that's right, okay. So it's going to be like infinity over e to the infinity, which is infinity. So how do we do that? Well, we're going to use L'Hopital's rule. So we'll say, all right, this is also going to be equal to 1 over 2 e to the 2x. And obviously, if you plug in infinity into here, you're going to get 0. So infinity, if you get that, you get 0. And then if you plug in 1/2 now, f of 1/2, we're going to get 1/2 over e to the... Okay, I apologize. I just realized that there was a typo in here. I fixed it on one version. I forgot to switch it over to the other version. So these are the actual answer choices that are supposed to go with this problem, because none of those were right. So I was just realizing as I was working this, hold on, the right answer is not here. So anyways, as we're doing f of 1/2 is 1/2 over e to the 1/2 times 2, which is 1. So it's e. This is equal to 1 over 2e. Right, so that's 1 over 2e. I want to find the maximum value of f, so the biggest out of these. This is negative, this is 0, this is positive, so it's obviously going to be this one. So we're going to go with 1 over 2e, which is b. Okay? Let's go down to question 5. Which of the following is the solution to the differential equation with the initial condition f of 1 equals 1? Alright, what I can do here is I can separate this and integrate like I normally do, right? So we'll separate this, look at 1 over y squared dy equals x dx. If I integrate both sides, this is going to be y to the negative 2, right? That's going to be y to the negative 1 over negative 1, which is negative y to the negative 1, which is negative 1 over y. On this side, we'll get, this is just simply x squared over 2 plus c, right? So if we set these equal to each other, right, because we have this differential equation, we'll have negative 1 over y equals x squared over 2 plus c. If you're not, I kind of went a bit fast there. You just kind of integrate both sides, and you only need 1 plus c, of course, right? So now to solve this, I can take the reciprocal of both sides, and I'll get, let's do it over, we'll do here. We'll get negative y equals 1 over x squared over 2 plus c, and then I can take a negative, and I'll get y equals 1 over negative x squared over 2 plus c. Again, the plus c doesn't really change when you put a negative next to it. It just kind of sucks it up and stays as plus c, right? So now what we can do to find the value of c is we can use this initial condition f of 1 equals 1. So I'll put a 1 on for y and for x. I'll get 1 equals 1 over negative 1 squared over 2 plus c. This is going to be negative 1/2, right? So 1 squared is equal to 1, so I'll just get rid of that. And then I can take the reciprocal of both sides again, and I'll get 1 equals 1/2, negative 1/2 plus c. So c is equal to 3/2. So now what I can do is I can say, okay, I'll plug this back into here, and I'll get y equals 1 over negative x squared over 2 plus 3/2. As you can see, that's not anywhere in this answer choices here. So what I can do is I can get rid of this fraction by multiplying by 2 over 2. That'll give me 2 over negative x squared plus 3. And I can just switch the order of these two. So we'll get 2 over 3 minus x squared. And this is my final answer, and 2 over 3 minus x squared, that appears right here. The answer is D. Okay? Alright, question number 6. If the average value of f prime of x over the interval 0 to k is k, and f of 0 is -1, which of the following expressions is equal to f of k? Okay, so this is kind of an interesting application of the average value, right? So just write out the average value formula real quick. It's 1 over b minus a times the integral from a to b of f of x dx, where you want to find the average value of f of x over the interval from a to b. So in this case, we're finding the average value of f prime of x over the interval from 0 to k. So in our situation, we're going to have the integral from 0 to k, and then out back here, we're going to have a 1 over k minus 0, which is 1 over k. And then inside, we're going to have f prime of x dx. And so when you integrate f prime of x by the fundamental theorem of calculus, you're just going to be left with f of k, right? Oops, not f of k minus f of 0, right? So now this is equal to k, right? Because we told that the average value is equal to k. So this is my average value, and it's equal to k. So now I know that f of 0 is -1, so I can replace this f of 0 with a -1, right? So the negative of -1 is going to be a positive 1. Now we just need to solve this for f of k. So I can multiply both sides by k, and I'll get f of k is equal to, f of k plus 1. F of k plus 1 is equal to k squared. And so f of k equals k squared minus 1, and that is A. Question 7. Let R be the region bounded by the graphs y equals x and y equals x to the fourth. R is the base of a solid, and for the solid, each cross-section perpendicular to the y-axis is a square. Find the volume of the solid. Now be very careful here. I've said y-axis, okay? So what you don't want to do is you just want to go on autopilot and just use it like it's perpendicular to the x-axis, because most questions talk about perpendicular to the x-axis, right? And also, by the way, normally you'll see questions like this on the FRQ section, but it's on the MCQ section. It's the same thing, just with easier numbers, right? Whole numbers are like easy fractions. So let's actually draw a quick sketch of this. That's a good use of our time, I think. And by quick sketch, I mean really quick sketch. So like, that's y equals x, that's y equals x to the fourth, and you can see here that we have this is our region R that we're talking about, right? This is x to the fourth. But notice that when we're talking about cross sections perpendicular to the y-axis, we're going this way. So it's going to look like this, cross sections. So we're not actually dealing with x here, we're dealing in terms of y. So what I want to do now is I want to rewrite each of these things in terms of y. So I have, the first one's going to be x equals y, easy enough. And the second one is going to be, since y is equal to x to the fourth, I have that x is equal to y to the 1/4, right? So I want to get the equation for each of these. It's going to be the one on the right minus the one on the left. This is the right, this is the left. So right minus left, that's going to be the x to the fourth one minus the x one. So it's going to be y to the 1/4 minus y. Now what this is this line here, and we want to take squares, right? So if this is the side, you can think of like each of these lines as the side length of a square. Let me zoom in real quick. Right, so if I were to have these cross sections, I could just make a bunch of squares out of them, like that. Right? So, zoom back out. Okay, so basically what I'm doing here is I'm saying, okay, this is the side length of that square. And to find the area of each square, I need to square this, right? And if this was a calculator question, you just go with this, but since this isn't a calculator question, we actually have to expand this out. So if we expand this, we'll get y to the 1/2 minus 2 times y to the 1/4 times y plus y squared. So it's going to be y to the 1/2 minus 2y to the 5/4 plus y squared. And this is the area of each square. All I have to do now is integrate it from, okay, so where is this intersection point? When triggers intersection point, right? It's pretty easy to just know it off the top of your head, right? X and x squared, that's obviously going to be at 1, 1. Okay, so we're going from 0 to 1 here. And it's going to be y to the 1/2 minus 2y to the 5/4 plus y squared dy. And And then when you integrate this, you'll get y to the 3/2 times 2/3 minus 2y to the, you add 1, so you're going to get 9/4 times 4/9 plus y cubed over 3, all from 0 to 1. Notice that if you put in 0 into all these, it's just going to wipe them all clean, so we're just going to have to put in 1. So we're going to get 2/3 minus, if you plug in 1 here, you're going to get 2 times 4 is 8, 8 over 9, and then 1/3 plus 1/3. 2/3 plus 1/3 is 1, and 1 minus 8/9 is 1/9. So we're going to go with E there as our best answer. Okay. Number 8. For what values of k, values of k, where k is not equal to 0, does the function f of x equals the natural log of kx satisfy f double prime of x, f double prime of 1 equals 1? Alright, so I think we should start off by finding f double prime of x, right? So we'll start by finding f prime of x, and so it's going to be 1 over kx times the derivative of kx, which is k, and we're just left with 1 over x. Alright, now notice, f prime of x has nothing to do with k. K just disappeared, right? So what's going to happen now is that f double prime of x is going to have nothing to do with k either. So it's not going to be like only for specific values of k that this is going to be true. It's either going to be always true or never true, right? It doesn't matter what k is going to be because k isn't even part of the expression. So I can just eliminate these 2 right off the bat. It's either going to be all or no. So we'll find the second derivative of x, and we'll get, okay, that's going to be negative 1 over x squared, right? This is x to the negative 1. So you raise it to the, you subtract 1 and then do all that. So you get 1 over x, negative 1 over x squared. And then notice if I plug in 1 into here, I'll get f double prime of 1 equals negative 1. So f double prime of 1 is never going to equal 1 no matter what k is. That has nothing to do with anything. So the best answer here is actually no values of k, because no values of k will make this equal 1. Okay, now we get into one of my favorite problems, question 9. The figure above shows the graph of g, which consists of 2 line segments in a quarter circle. If f of x equals the definite integral from x to negative 2 of g of t dt, what is the absolute minimum value of f on the interval from negative 2 to 8? Okay, so how do I do this? Well, the first thing that I'm going to do is I'm actually going to notice that, okay, it's going from x to negative 2, but notice where we're starting in negative 2. So it's actually going to go from, like, if x is like 0, we'll have 0 to negative 2, or 1 to negative 2, or something like that. That's going to be kind of unusual, right? So what I want to do is I want to go from the smaller number to the bigger number, so I'm actually going to flip f of x. So look at f of x equals negative integral from negative 2 to x of g of t dt, right? And now what I can do here, if I want to find the absolute minimum value of x, I can just look at this part, right? And I want to find the maximum of this, and then the negative will just make that the absolute minimum. So now what I want to do is I want to find the absolute maximum of this. So remember, this is just the area under the curve. So we're starting in, for example, negative 2, and so we're just going to find the area under the curve, and we're going to say, okay, where is that area the maximum? Okay? And so the way we do that is by taking the derivative again and setting it equal to 0, right? So if you take the derivative of this function, g of t dt, we're just going to get g of x. And if we set that equal to 0, we have 2 situations. We either have x equals 0 or x equals 4, okay? 0 and 4. So now I need to figure out the maximum of this, remember? So we're going to set up another table like we did in one of the earlier questions. We have x here, and this whole negative 2 to x of g of t thing. And so we have our endpoints, which are going to be negative 2 and 8, and our critical points, which are going to be 0 and 4. And now we need to find the absolute maximum of this, right? Because remember, we want to find the maximum of this to find the minimum of f. So to find the maximum, we are going to evaluate by putting x into each of these x values into this expression. Okay. So if we start off with the negative 2, well, the integral from negative 2 to negative 2 of g of t is just going to be 0. for 0, the integral from -2 to 0, that's going to be this triangle here, right? So it's going to be 1/2 times 2 times 2, 1/2 times 2 times 2, that's just going to be 2, right? For 4, it's going to be this area plus this area. Notice that this triangle and this triangle, they're equal in magnitude, but they're opposite in sign. This is above the x-axis, it's positive. This is below the x-axis, it's negative. So it's going to cancel out. And so the area from -2 to 4 is just going to be equal to this semicircle. Notice, by the way, that the semicircle is under the x-axis. So it's going to count as negative. Okay? So we're going to have pi r squared, or negative pi r squared, I guess, over 4, because this is only a quarter circle. And since the radius is 2, so we're going to have 2 to 4, it's going to be negative pi times 4 over 4, which is negative pi. So we can put negative pi in there. And then for 8, it's going to be this quarter circle plus this triangle. And this triangle is going to be, this is 4, and this is 2. So this area is going to be 1/2 times 2 times 4, which is 4. So this is going to be negative pi plus 4. Okay, so now to find the maximum of this, we're going to say, alright, which of these is the biggest? Well, this is 0, and this is negative, so we can get rid of those. Now we're left with two options, 2 or negative pi plus 4. Remember, pi is equal to about 3.1, right? So if we take negative 3.1 plus 4, that's going to be 0.9. So 2 is way bigger than that. This is definitely what's going to make our this expression maximum. So, this is going to be the maximum value of this expression. Okay, so if the maximum of this guy is 2, then the absolute minimum of f is going to be negative 2. So, A. 10. If f of x equals 2x and g of x equals square root of x, at what x coordinate does the composite function h of x equals g of f of x have a slope of n, where n is a positive number? Okay, so what we have to do here is we first have to find g of f of x. So g of f of x, we're going to take f of x, which is 2x, and replace it whenever we see an x in here. So g of f of x is going to be square root of f of x, which is square root of 2x, right? And so I want to find the slope, so I'm going to take the derivative of this, so h prime of x, right, because this is h of x. So h prime of x is equal to the square root of this, which is going to, remember, the square root of x, by the way, it's a good thing to keep in mind, is 1 over 2 square root of x. So square root of 2x is going to be 1 over 2 square root of 2x, but since this is a 2x, to multiply by the derivative of it, which is 2, so we're left with 1 over square root of 2x. Okay, now what we have to do is we have to say, alright, if this is slope of n, right, so this is n, my slope is n, I want to find the x coordinate where it's equal to n, so I'm just going to have to solve this for n, right? So first thing I'll do is I'll square both of these, so I'll get 1 over 2x equals n squared, and then I'll swap both of these, and I'll get 1 over 2n squared equals x. And this is the x coordinate at which my slope is 1 over, this is the x coordinate at which my slope is n. Alright, so the answer there is D, 1 over 2n squared. Alright. Question 11. There are three functions f, g, and t, such that f of x is less than or equal to t of x is less than or equal to g of x. What piece of information is needed to determine the limit as x approaches 3 of t of x? So we have to go deep back in your memory to Unit 1 limits for this one. Just think about, oh, the squeeze theorem. What did they tell me about the squeeze theorem? I needed to know some stuff, and then I could like squeeze one function between two other functions, and that would tell me the answer. So how do we do that? Well, okay, this is this kind of question you either know it or you don't. It's really hard to like figure it out just from your own knowledge. So we're going to say we need two pieces of information to determine the squeeze theorem. First is this piece of information they give us here, where f of x is less than or equal to t of x, which is less than or equal to g of x. And the second piece of information is that the limit as x approaches the value that we want, in this case is 3, of f of x is equal to the limit of g of x at that point. And then we can say that, oh, if both of those limits are equal to 3, well, this one must be 3 also, because that's right in the middle of those two, right? So we have functions like this, and then functions like this, and then functions like this. That's what, okay, so this limit is 3, this limit is 3, so the limit in the middle must also be 3. That's basically what we're doing here. And so the correct answer for that would be E. Question 12. Position of a particle is given by x of t is equal to t squared plus 2 to the t. What is the acceleration of the particle at t equals 3? Finally, a straightforward question, right? So all we've got to do is find the acceleration by taking the second derivative of the position. Okay, so we'll start by the first derivative, which is the velocity. That's going to give us 2 to the t plus ln of 2 times 2 to the t. Next, we find the acceleration by taking the derivative of this, which is going to be equal to 2 plus ln squared of 2 to the t. And then now I'll find the acceleration at time t equals 3. I'll plug in 3, and I'll get 2 plus ln squared of 2 times 2 to the 3, which is 2 plus 8 ln squared of 2, which is a. Question 13. Let f of x equal the integral from 0 to x of g of t dt. Use the left Riemann sum with the 4 subintervals indicated in the table to estimate f of 7. Okay, so f of 7, by the way, is just the integral from 0 to 7 of g of t dt. So I'm going to use a left Riemann sum with 4 subintervals, 1, 2, 3, 4, to do that. Okay, so for a left Riemann sum, I'm going to take the difference between the x values and multiply by the left of the g of x values. So for this first one, the difference between 0 and 1 is 1, and the left value is 3. The difference here is 2, and the left value is again 3. The difference here is 2, and the left value is 4, and finally the difference is again 2, and the left value is 6. So now it's 3 plus 6 plus 8 plus 12, right? 3 plus 6 is 9, 8 plus 12 is 20, 20 plus 9 is 29, and that is B. 14. Final question in this section. F of x is the piecewise function defined as f of x equals secant of x for x is less than 0, and negative x squared plus 1 if x is greater than or equal to 0. Which of the statements must be true concerning f of x on the interval from -1 to 1? Oh, I love these kind of questions. It's everyone's favorite. I'm sure it is, yes. Okay, so the first statement says that limit as x approaches 0 of f of x exists and is equal to f of 0. Well, let's find that limit, right? So as we're approaching 0 from the left side, it's going to be equal to secant of 0, right? And I was nice here. I gave you secant of 0, which is 1 over cosine of 0, which is 1. And then negative x squared plus 1, that's just going to be negative of 0 squared plus 1, which is 0 plus 1, which is 1. And then obviously f of 0, since this is it's going to follow this branch for x is greater than or equal to 0, f of 0 is just going to equal 0 plus 1, which is 1. So this is f of 0 is also equal to 1. So you can see they're all equal to 1. So the limit as x approaches 0 of f of x does exist, and it's equal to f of 0. So this one is check. 2 says f prime of x is defined at x equals 0. So if we look at the second one, what we've got to do here is we're going to take the derivative of it and look at whether those meet. So we'll take f prime of x, and then if I take the derivative of secant, remember the derivative of secant is secant tangent, and the derivative of negative x squared plus 1 is negative 2x. So I want to figure out f prime of 0, right? F prime of 0 is going to be secant of 0 times tangent of 0, which is 1 times 0, which is 0, and then negative 2 times 0, which is 0. So as you can see here, these are both equal, so f prime of 0 is defined, and it's equal to 0, so it is defined at x equals 0, so let's check. And then number 3, f of x has an inflection point at x equals 0. So when I originally designed this question, I wanted to include a graph of this function, because if you graph this piecewise function, it really looks like there's an inflection point at x equals 0. Like, it's really, like, I was really tricked by it at first. But it turns out if you actually look at the math, there is no inflection point at x equals 0. And the way we're going to figure that out is by saying, okay, if there's an inflection point, the second derivative has to switch signs and go through 0, right? So either we have a positive to 0 to negative, or negative to 0 to positive, right? And so either way, it has to go through 0. But if we were to look at this guy, and we were to take the second derivative of it, we'd get, so the first derivative is negative 2x, the second derivative is negative 2. This is never going to equal 0, right? So the second derivative is never going to equal 0. So at this point, x equals 0, you're not going to have the second derivative be equal to 0, so you don't have an inflection point at x equals 0, okay? Even though I encourage you to graph this, it's really interesting how close it looks like to a function where there is an inflection point at x equals 0. But don't believe in the graph, believe in the math, and the math tells us that there is a second derivative of negative 2 when you're coming in from the right side, which is not equal to 0, so therefore there is no inflection point at x equals 0, so we can cross off that, and that, and that, and that, because this is wrong. So we have 1 and 2 is right, 3 is wrong. That gives us B as our final answer there. And that is the end of section 1, part A. This is the non-calculator section, the calculator section, which is a little bit shorter. And then we have the FRQs as well. And if you go all the way to the bottom, you have the answer key, yada, 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 right? So you have all that. And, but for now, we did go through the non-calculator section. I hope you found those questions interesting, helpful, preparing you for your AP exam, whatever it may be, right? And I hope you found, hope you'll come back for the other 3 parts. And yeah, like and subscribe, and I'll see you next time. So, goodbye.